Hello, welcome back to BLENDERSUSHI live noding. In this video, we're gonna touch a little bit of the basic math. Once again, it's about math wave. I haven't talked about square wave. I talk about sine wave. I talk about like a ping pong kind of motion and like a modulo, like to do the repeat and looping. I have not talked about square wave. Square wave is one of the kind of like a wave pattern that's really useful. And we see it all the time whenever we see something that's like kind of like flip flop or turn off and off, like every cycles and gonna repeat and again. That's a square wave basically. So let's use animation nodes to investigate that. So if we're drawing like a mathematical wave, first of all I'm gonna just use grease pencil to do it. So wave, this is a wave in math, and the basic one we have sine wave, which is basically looking something like this. And then we have like a modulo kind of wave that's kind of repeating. So it's looking like this, and then it repeats and goes back to 0 and then repeat. And then I believe we have also, I think it's a sawtooth, or I think it's saw wave that's more like that, 0 to 1 back to 0. I call it like a ping pong kind of pattern. We can use time repeat to get a ping pong. There's also now the square wave, which is looking something like this. In one cycle, it goes from 0 to 1 without any kind of intermediate value. It just like pop to 1 and then stay at 1, hold it back to 0, hold it at the 0 value, and then go to 1 and back to 0. That's a square wave, and we're gonna take a look at this guy. Okay, apparently there's a formula for that, but let's just open up animation nodes and let's create it. This formula actually I learned from Andrew Glassner for his processing tutorial. He mentioned about square wave. Apparently the formula is something like this: time modulus w divided by u. Is it smaller than if time divided time modulo w smaller than u? If yes, give a value of 1. If not, give it a value of 0. Something like this. This is in processing, where I believe this is how I remember it. So this is, if this is like a square wave, a single cycle is like that much. The u is the in-between value, the middle value. So it's kind of asking, are you time modulo w is of course like time goes from start to the end, right? And goes back to start to the end. It's like gonna be looping, and it's gonna asking, okay, is it smaller than u? If yes, then stay at 0. If not, and go up to the second number. So it's like just a flip-flopping between two numbers. If you don't understand it right away, it's okay. It's easier to see how this value is affecting our result. So this is animation node square wave, study of square wave. Let's move this guy and in a square wave kind of pattern. First of all, give it a time info node, and I'm gonna turn this off and turn it on. Okay, now and then object transform output. It's gonna be this object, and then we're gonna move him in the x-axis. If we just plug in the frame to the locations, it's gonna move in the x-axis. Okay, it's gonna move really fast. So we might want to have like math here to make the time goes slower. So that's just to make the time fraction of the original value. So it moves slower. Now we're gonna put a modulo thing. Here's another math, and then we're gonna put a modulo here. Okay, the modulo, what's the value here in the B? Maybe just 10. That means the time is gonna loop over after kind of like 10 frames. Let me actually change this to 1. See, every 10 frames gonna go back and repeat and repeat. That's the loop. This is a loop. So this is the conditional, and then blah blah blah. Okay, we want to compare the value, so we're gonna use a compare node. I hardly use compare node, but this is really useful. Conditional is not easy, but it's super useful. You're comparing value. Is it A equal B, or A not equal B, smaller than B, smaller or n equal B? All this is a compare node. It's comparison in a math, and the result's gonna be true or false. We're gonna check real quick. So currently it's true because A equal B. Okay, if I change it, it's gonna be false because it's no longer equal. I also gonna display this value if you just for the modulo to see the number. So 0 to 10, back to 0 to 10. Okay, that's the modulo. That's looping. Okay, that's fine. And then let's do the comparison thing. Is it smaller than U? Okay, maybe U is 5, and we plug in this result into the A, and then now if we check it out, it's gonna be like true and then false. It's really fast at the moment. It's let's see, 1, 2, 3, 4, 5, and then it becomes true. Go back to false because it's a equal B. We want it to be A smaller than B or something. So this is 5. Let's try it again. 1, 2, 3, 4, 5, true, and then become false. 2, 3, 4, 5, and it become true again. So it's a this is I think this is the square wave. So we already have something. True and false. It's gonna give like a value that's 0 or 1. We can use the conditional. Compare and conditional. Actually, it's called switch. So switch is really useful. So depending on the conditions, true or false, it's gonna give the value that's, let's say this is minus 10 or 10. Okay, the result goes into the x of our cube. So now this is actually the formula. This is what's happening here. Time modulo W smaller than U, 1 or 0. So let's play back. So now we can see it's doing the flip-flop thing. And we can say, okay, if it's true, minus 5. If it's false, 5. So that's working for us. That's actually the square wave. It's flip-flop is really useful for maybe if you have like Christmas light on and off, on and off. Yeah, it's gonna work for us. I'm gonna show you real quick, but I want to also show you that instead of using this formula stuff, Um, let me join this. Okay, maybe this one should be outside. How to delete this guy? Never mind. So frame, if we are using another way to get the value, the flip-flop thing, we can actually use the sine wave. So we know that sine wave goes -1 to 0 to 1 to minus. It's kind of doing this smooth wave. How to turn this guy into something like this? We can use let me debug this, show you the number. So see, it's going -1 and then up to 1 and -1, up and down. You can use math and floor or ceiling. Either one of these gonna give you like a value that's kind of making this smooth become kind of square. I'll show it to you. If we use floor, for example, and the results plug into our box, you will see it's doing this 0 -1, 0 -1, 0 -1. I believe that's what's happening. So 0 -1, 0 -1. It's very, very fast. If we use the ceiling, it's gonna be the opposite. 0 1 0 1 0 1. So 0 and 1 is square wave. It's because it's just a flip-flop between two values. And we can use map range. And for this value, we can say, okay, this is currently 0 and 1. Turn it into -5 and 5. And plug the value there. And I believe we have our flip-flop. So this is it's a lot simpler. It's something that I use most of the time. This is the correct formula, kind of. You can, but you will learn something by comparing value. You can actually have more control over the square wave. You can have square wave that's kind of short and then longer here. So this is very, very useful sometimes. So this is like a put a hold. Sometimes if you're animating a character using value, sometimes you want to make characters kind of like moving like this and then stop, hold it, and move again, and then hold. So you get this kind of square wave. You need that. You can always like mix all kind of waves into more interesting motions. Anyway, this is just the basics. So now let's do like a flip-flop kind of thing with our box. So instead of moving our objects, we're not gonna move the objects. We're just gonna make it changing color. Okay. So with our material, make it shadeless, and then turn on object color. With object color on, we can just change this object color into any color. It should now show up in the 3D view. I always use this. It's good for demonstrations. So let's make this flip-flopping in the color. So object attribute output. Select our object, and then we're gonna flip-flop the color. It says, okay, value has wrong type as usual. We're gonna use mix color node, and we're gonna flip-flop the color, maybe green to red. Okay, plug the color here, plug the vector controlled by the flip-flop, and there you go. We have the value. The value is probably goes over. It goes up too high. We want to climb the vector. Currently it's like -5 to 5. We don't want that. It's actually supposed to be like -1 to 1. So we don't need to clamp it. We still get a interesting value. -1 and 1, 0 and 1. Okay. Well, anyway, we get our flip-flop. It's really, really simple. It's really basic, but it's useful. You can make a, you know, like a light goes on and off, or like a ambulance, or maybe a police, red, blue, red, blue. Okay, that's fairly useful. How about let's have a little bit of fun and let's make like instance of this guy. So from all this simple setup, we're gonna add a little bit of complexity. Just make a lot of them. Object instancer. Select our object. How many instances we don't know yet. Let's put it in grid. Grid mesh here, and let's lay it out like a duplicates of this guy. So this is our master cube. We're gonna loop through all the vertices position, and then we're gonna bring in the object list here. This is our object. How many duplicates do we need? Depends on the number of vertices, so just plug it in to the instance. And so the object, I think we are ready. Objects, we don't need to use copy full objects and deep copy. We're just gonna lay out our object in the grid. Location on, object, vector. Okay, there you go. Currently it's all white because we haven't done anything with the color. Here, this is our flip-flop stuff. We're gonna use this guy, of course. Bring all this in. We're gonna flip-flop between two values. This is our object. Flip-flop. Okay, it's happening. Yeah, it's flip-flopping. All doing the same thing, but we can use time delay or delay time. Now offsetting the time using, okay, let me organize a little bit. So this is our grid mesh points template, and this is our instance cube being placed on the template. Now inside the loop, if we are using the index to offset the time, plug into the sine, and then we have something like this. Pretty interesting, right? Can you sometimes when you're playing around with wave pattern or math itself is kind of so complex that you don't want to look at it. But if you turn it into something like a pattern, it's starting to get more interesting, I think. And you start to see, okay, I saw that kind of pattern, you know, in the everyday life. Maybe it's just a flipping card, like in the airport, or I don't know. You definitely have seen something like this, and you kind of wonder how does it really work? What if I change this? So ceiling, time, delay. What if with the delay we multiply it, offset it more, like 10 different. So now we can see, okay, so it's kind of like a, it certainly have some kind of a repeat in the pattern. Smaller number, bigger, increase it. This one is especially interesting. See, it's like a kind of a linear. I think this pattern is also used in the Christmas tree sometimes. Yeah, you can also use like maybe random number. Plug the index into the seed, and min and max any value, you know, just test it. And plug this into the multiplier, and you get something that's more interesting than random, because this one is doing a loop, and then but it's actually kind of jumping around as well. It's very, very interesting, I think. Currently it's a little bit slow with 400 boxes. Let's make it 64 or maybe 10 times 8. 10 times 20 times 8, 12 times 8. Yeah, that's more interesting. This is our master, of course. We can hide it. If you want to see the in full speed, just go like this and turn on texture, turn on material, turn on texture. Okay, that's in full speed. Back to compositing. Now, like I said, with our flip-flop here, we have more control with the condition here. So if true and if false, maybe if true -1, if true 0, if false 1. Let's do that. So frame. So this guy is actually working as well up above there. So this is the start of our loop, and there's the mask and random number, etc. Time delay. Now we plug the time delays into this guy, and plug the result of switch into our map range. Actually, this output can go to the factor, and this should work. So same result, but we can change this compare. You see, more blue and maybe more red. It's just a different way to look at it. In fact, this is probably it's being used in the casino. Red is when people can actually win, like winning in jackpot. Blue is when they're always lost. Okay, that's how they trick you. If it's 50-50, you get something like this. If it's I don't know, if you give something like this, and then the casino will go bankrupt. So this is 50-50 chance. Flip-flop. Okay, that's yeah, I guess that's fairly useful. Since we already learned about particle as well, I kind of want to incorporate that. But particle instancing, and then sometimes I like this kind of control with particle instancing. Currently, I'm kind of thinking of a way to incorporate particle instancing and animation nodes and sphere choke. Yeah, while I'm thinking, you can of course play around with this. You can do something a little bit crazy with this color. So they're flip-flopping. If you want, you can have like a, let's use the combined color. I'm trying to improvise here. Just a bonus, as a bonus, combine color, HSL. We want maybe save first, file save as. I'm gonna give like random value for all of this, and let's see, have a look. Random number. Index plugged into the seed, always always, and the output goes into the hue, saturation value. Give it a value, plug this guy in there and plug this guy in there, and now we have flip-flop, but they are all random value. It's definitely more interesting, and it gives that kind of unusual complexity. I wonder if one of them is like black. See, it's like a disco party kind of light. You can have less color, or more color, less color. You can control it right here. All black, and then suddenly, okay, let's start the disco music, and then start slow. It's kind of more and more. This is just math pattern until it's all like colorful. Yeah, this is just a touch on a square wave. I use it time to time, but sometimes I hardly talk about square wave. I always talk about, since we have like noise, we have random, we can kind of get this kind of result, but this is square wave. You have more control over the flip-flop of value. Yeah, I guess this is something I should talk about. Okay, thanks again for tuning in to this live noding. Hopefully this is useful for you. I'll see you